Hello my dear children, once again welcome to our physics class. Hope you all are fine over there. Children, in the previous session we had discussed about the standing waves for an open and closed tube system. Today we are going to discuss the last topic of this chapter, that is beats. Actually the last topic is Doppler effect, but as a part of syllabus reduction it has been deleted from our topics. So the last topic of this chapter is beats. So you are familiar with this word beats, and this word is closely related to music or sound waves. So what do you mean by beats, or how are these beats formed? See, when two sound waves of nearly same frequency and amplitude traveling in the same direction are superimposed, a periodic variation of sound intensity, that is waxing and waning of sound, is produced. This is called beats. For example, if we consider two sound waves. So here when two sound waves of nearly same frequency. So consider two sound waves like this, and their frequency and amplitude must be nearly same. So here their frequencies and amplitudes are not exact. The frequency is variation, that means the two waves slightly vary in their frequency. So if frequency of one wave is 24 Hertz, then frequency of the second wave may be 23 Hertz, like that. Okay, so there is a slight variation between the frequency of both the waves, and when two such waves of nearly same frequency and amplitude travel in the same direction. So here you can see both the waves travel along the same direction, that is along this direction. And when two such waves are superimposed, that means if we consider two such waves like this, and when these two such waves travel along the same direction like this, and when these two sound waves are superimposed, a periodic variation of sound intensity, waxing and waning of sound. So here you can see the resultant wave pattern will look like this. Okay, the resulting wave pattern will look like this. Here you can see a periodic variation in the intensity of sound. Here we have maximum, here it is minimum, again maximum, minimum, maximum. Okay, so this maximum area is called waxing of sound. Minimum condition is called waning of sound. So waxing and waning, waxing, waning, waxing, waning. A periodic variation in the intensity of the sound is produced. So whenever two sound waves which varies slightly in their frequency and amplitude travel along the same direction, and when they are superimposed, there will be a periodic variation in the intensity of the resultant sound wave. Periodic variation means one waxing, after waxing, waning of sound is produced, after waning, again waxing of sound is produced. And this resultant sound wave is known as beat. Okay, so there is an envelope. Within the envelope you can see the variation of the sound waves. Okay, so this is called beats. And let's try to find out an expression for the beat wave. Also let's try to find out an expression for the frequency of the beat. So for that we are going towards the analytical treatment of beats. Okay, so from the analytical treatment it is possible to obtain an expression for the beat frequency. So consider two waves. Consider two sound waves traveling along the same direction, and these two sound waves slightly vary in their frequency. So let the first sound wave be represented by y1 equal to a sin omega 1t, and you know omega is equal to 2 pi nu. So omega 1t will be 2 pi nu 1 into t. So a sin omega 1 is equal to a sin 2 pi nu 1t, and a sin omega 2 equal to t equal to a sin 2 pi nu 2 into t. That means the two sound waves are having different frequency. Frequency of one sound wave, first one is nu 1, frequency of the second one is nu 2. Now when these two sound waves traveling along the same direction are superimposed, you will get a resultant wave. And the expression for resultant wave is obtained using the superposition principle. So according to superposition principle, the amplitude of the resultant wave is obtained y is equal to y1 plus y2. So y is equal to y1 plus y2, where y represents the resultant wave. And here y1 is a sin nu pi nu 1 t. So that is y1 is equal to a sin 2 pi nu 1 t plus y2 is a sin 2 pi nu 2 into t. Then again here a is the common factor, so it can be taken outside. Then we are left with a into sin 2 pi nu 1 t plus sin 2 pi nu 2 t. And we have already studied one identity in maths. Sin a plus sin b is equal to 2 sin a plus b by 2 cos a minus b by 2. So here a can be taken as nu 1. That means 2 pi nu 1 t. That can be considered as a. And 2 pi nu 2 t can be considered as b. Okay. So y is equal to a into 2 sin a plus b by 2. So first term will be 2 sin. What is a plus b? A plus b is 2 pi nu 1 t plus b is 2 pi nu 2 t by 2. And here 2 pi t are the common factors. So we will get equal to 2 pi into nu 1 plus nu 2 into t by 2. So that is written here a sin 2 pi nu 1 plus nu 2 into t by 2. Similarly, a minus b by 2 will be 2 pi nu 1 minus nu 2 by 2 into t. And here this 2 and this 2 will be cancelled. Similarly, this 2 and this 2 will be cancelled. And we are left with y is equal to 2 into a sin pi nu 1 plus nu 2. This is nu 1 plus nu 2 into t cos pi nu 1 minus nu 2 into t. Now here the amplitude of the resultant wave will be 2a cos pi nu 1 minus nu 2 into t. That will be the amplitude of the resultant wave. And the sine term will represent the rest of the wave or progressive part of the wave. 2a cos pi nu 1 minus nu 2 t represents the amplitude of the wave. So next we want to find out the condition for maxima and minima of this amplitude. So amplitude will be maximum if this is the amplitude 2a cos pi nu 1 minus nu 2 into t is the amplitude, and this amplitude will be maximum when this term is maximum, and this term will be maximum when the value of cos is maximum. So you know the maximum value of cos theta is plus or minus 1. And at which condition cos theta will take plus or minus 1? When theta is 0 or pi or 2 pi or 3 pi, etc. like that. So generally we can say cos theta takes maximum value, that is plus 1 or minus 1 value, when theta is the integral multiple of pi, or when theta is equal to n pi. So here theta is, or the angular part is pi into nu 1 minus nu 2 t. That is the theta part. So when pi into nu 1 minus nu 2 into t, that is theta, equal to 0 pi, 2 pi or 3 pi, you will get the maximum value for cos. So generally we can write when pi into nu 1 minus nu 2 into t is equal to n pi, you will get maximum value. So here this pi and this pi will be cancelled, and we are left with nu 1 minus nu 2 into t is equal to n. Therefore t equal to n divided by nu 1 minus nu 2, and the value of n starts from 0, 1, 2, 3, etc. So at this values for t, you will get maxima. So amplitude is maxima when n equal to 0. When n equal to 0, time period is 0. Then when n equal to 1, t is equal to 1 by nu 1 minus nu 2. When n equal to 2, t is equal to 2 by nu 1 minus nu 2. When n equal to 3, t is equal to 3 by nu 1 minus nu 2. So when t is equal to 0, 1 by nu 1 minus nu 2, 2 by nu 1 minus nu 2 or 3 by nu 1 minus nu 2, amplitude is maximum. Okay, so this is the condition for maximum amplitude. And at these times, amplitude will be, of the resultant wave will be maximum. Now, similarly, when will be this amplitude minimum? So this is the amplitude part, and amplitude will be minimum when this expression is minimum. That means when the cos value takes the minimum value 0. And what is the general condition for the cos theta to take the value 0? When theta part must be equal to 2n plus 1 pi by 2. That means when theta is the odd integral multiples of pi by 2. For example, when theta is pi by 2, that means when theta is 90 degree, cos pi by 2 will be 0. And when theta is 3 pi by 2. Okay, that means when theta is 3 pi by 2, again cos theta will be 0. When theta is 5 pi by 2, cos theta will be 0. So whenever the angle theta will be odd multiples of pi by 2, the value of cos theta will be 0. And this odd multiples of pi by 2 can be generally written as 2n plus 1 pi by 2. Here when you put n is equal to 0, you will get the value as pi by 2, isn't it? And when n is equal to 1, what you will get? 2 into 1, 2, 2 plus 1, 3. So it is 3 pi by 2. When n equal to 2, you will get 2 into 2, 4, 4 plus 1, 5 by 2, 5 pi by 2. See, this is the expression for the odd multiples, general expression for the odd multiples of pi by 2. Next, from here, this pi and this pi will be cancelled, and we are left with t is equal to 2n plus 1 divided by, here 1 2 is there, so 2 into nu 1 minus nu 2. So minima is obtained at times 2n plus 1 by 2 into nu 1 minus nu 2. Here also when n is equal to 0, when n equal to 0, you will get time t is equal to 1 by 2 into nu 1 minus nu 2. When n equal to 2, you will get t is equal to 3 by 2 into nu 1 minus nu 2. So minima is obtained at times 1 by 2 into nu 1 minus nu 2, 3 by 2 into nu 1 minus nu 2, like that. Now what is the time interval between two successive maxima and minima? See, this is maxima, isn't it? So between two successive maxima, what is the time interval? So this is first maxima. First maxima is obtained at 0 and second maxima is obtained at 1 by nu 1 minus nu 2, isn't it? So what is the time gap between these two? Time gap is 1 by nu 1 minus nu 2 minus 0. So here the time period between two successive maxima, time period is capital T, is 1 by nu 1 minus nu 2, isn't it? Similarly, these are two successive minimas. And what is the time period or time interval between these two successive maxima? So just subtract 3 by 2 nu 1 minus nu 2 from 1 by 2 nu 1 minus nu 2. So 3 by 2 nu 1 minus nu 2 minus 1 by 2 nu 1 minus nu 2 will be 3 minus 1 by 2 into nu 1 minus nu 2. So 3 minus 1 is 2, that is 2 by 2 into nu 1 minus nu 2, and you know 2 will be cancelled and we are left with 1 by nu 1 minus nu 2. Okay, so here also the time period or the time interval between two successive minima is 1 by nu 1 minus nu 2 and the time interval between two successive maxima is also 1 by nu 1 minus nu 2. That is, the time interval between two successive maxima and minima in the case of beats will be same, and that time period or the time interval is 1 by nu 1 minus nu 2. So if this is the time period, then what will be frequency? Frequency is the reciprocal of time period, isn't it? So reciprocal of this time period expression is nu 1 minus nu 2. So frequency of minima and maxima is nu 1 minus nu 2. That means this is the expression for beat frequency. So what is the expression for beat frequency? It is nu 1 minus nu 2. So beat frequency, the expression for beat frequency is nu 1 minus nu 2. So if we are obtaining two waves of frequency 254 Hz and another one of frequency 256 Hz, and these two waves superimpose to form beats, then what will be the beat frequency? Beat frequency is nu 1 minus nu 2. So what is nu 1? 254, and what is nu 2? That is 256. And you notice a difference between them is minus 2, but we can just ignore this minus sign. So what will be the beat frequency? It is just 2 Hz. Okay, so like this we can easily find out the frequency of beats. So children, with this I am concluding this chapter. Notes of the topic have been uploaded. Just go through that. I'm not going to upload any YouTube video based on this topic. As you know, this is a derivation part. So it's better you go through the video lesson and just note down each step of this derivation so that it will be easy for you to study. So we will meet in the next session. Till then, take care all of you. Stay home, stay safe. Keep learning. Thank you.